Hi friends, good evening. Today's topic is carbon-free construction. Myself, Dr. K. Poongadi, Professor, Department of Civil Engineering, Director, CCMM, SR University, Warangal. Need for the carbon-free construction. The construction industry is booming day by day. It is good for the stakeholders like engineers, architects, contractors, material manufacturers, and the suppliers. But it creates a negative to the environment by releasing greenhouse gas and increases the carbon footprint. It is not good for the entire environment. The climate change, depletion of ozone layer, global warming, emissions of greenhouse gases, carbon footprints, and rise in sea level are the few important goals that affect all living beings and the lives of the people globally. Carbon footprint is the total amount of greenhouse gases, including carbon dioxide and methane, produced by the human activities such as burning of fossil fuels for electricity, heating, and transportation, and construction related work. After the 19th century, a big boom for the construction industry was established, especially with the Industrial Revolution, which led to the urbanization and the vertical growth of the structures. Fast and vertical growth is achieved in construction with the help of materials like brick, cement, steel, glass, aluminium, artificial paint, normal concrete, reinforced concrete, special concrete, and etc. Most of them are man-made materials and have a lengthy production process. Each and every process consumes energy expressed in terms of the emissions of carbon because they are the main sources of the greenhouse gas emission. Sources of the carbon emissions from the various sectors. We can start with the industry 32 percentage, transportation 23 percentage, building operations 28 percentage, building materials and construction 11 percentage, and others it is 6 percentage. So here building materials and construction related activities totally uh, responsible for 39 percentage, around 40 percentage of the greenhouse gas emissions is due to the construction related works. Other sources of carbon emissions because of the building materials, we can start with the cement. Cement is the prime material which releases 30 percentage of the carbon dioxide. Next, ceramic materials, including floor tiles, wall tiles, and etc. They emit 20 percentage of the carbon dioxide. Steel manufacturing nowadays without steel there is no construction. It releases 20 percentage because of the concrete 12 percentage, gravel 5 percentage, aluminium 3 percentage, prefabrication work 3 percentage, wood 1 percentage, PVC and other materials 6 percentage. These are the percentage of the sources of carbon emissions of the different building materials. So instead of these materials, if we are going for the alternate materials, then the construction related activities will be totally changed and the greenhouse gas emissions also may be reduced to some extent. Construction industry is a major source of carbon emission and uh, contributes 40 percentage of the global CO2 emission. So need for sustainable and eco-friendly practices are very, very important and essential. Carbon-free construction aims to eliminate the emissions of the greenhouse gases like carbon dioxide and also methane. So what is carbon-free construction? This carbon-free construction is aims the zero or minimal carbon emission. It focuses on low carbon materials and methods, use of renewable energy sources. So the life cycle approach will be totally different. Design will be changed. The entire design is based upon the what type of material we are using. Then construction practices. If the construction durability is increases, then greenhouse gas also in the increase will be more, and the services are operation of the buildings. So with that, we are concentrating from building materials, design, construction, and methods. Then we can reduce the maximum amount of carbon. So, sources of carbon in construction, cement production, steel manufacturing, transporting of materials from one place to another place, construction equipments, then energy consumption in buildings during operation. The impact and consequences of the carbon dioxide emissions. So, rise of global temperature because of that. What are the issues we are facing means shrinkage, changes of water supplies, geographical changes, changes of weather patterns, changes in food supply, acid rain, and increases in the remaining gas emissions. So here, uh, acid rain also plays major role in the due to the urbanization. Because of the urbanization, industry growth is more. That is good for the circular economy, but it is not good for the environment. Once the gases are available at atmosphere, when the rain comes, then rain will not be normal rain. The pH value of the rainwater will be less than 7, and it is considered as the acid rain. So acid rain totally affect the uh, crop rotation, health of the human beings and other living beings also. So what are the strategies in reducing carbon dioxide emissions in the building sector? First, we have to set uh, perfect standards and policies to reduce the uh, carbon dioxide, adopting low carbon technologies, then restriction of energy utilization, then impact assessment of the building process and materials. So these are the strategies we can follow to reduce the CO2 emissions in the construction site. Here, the standards and policies are very, very important. It should be created and implemented by the government, from the central government to the local bodies. All the things to be first established and followed, so that we can easily able to control the carbon dioxide emission. Globally, already we saw about that the construction materials are responsible for the 40% of the greenhouse gas. Due to the emission of the greenhouse gas, the changing climate, global warming, melting of glaciers and rising in sea level are the major issues related to the environment. In this, rising of sea level due to the melting of glaciers will play the major role, which affect the maximum cities of the cities throughout the globally, so that they the cities like Madras, they are situated at the zero reduced level, so that easily it will be occupied by the sea waters when the water level of the sea will increase. So the engineers and the scientists were warning the governments, within 2040 some places uh, will went into the sea because of the rise in seawater level, uh, maximum at South India. So we have to take care of the everything, and the cities to be protected from the seawater intrusion, or the land should be protected. These carbon emissions in construction can be reduced with the help of the carbon-free construction materials like bamboo, lime, biochar, ceramic powder, fly ash, crumpled rubber, and recycled aggregates. Reducing and replacing conventional materials with these less carbon materials will control carbon emissions to a significant level. A lot of research is done in this area to initiate the reduction of carbon emissions. The Green Building Rating System (LEED), that is Leadership in Energy and Environment Design, gives a framework for healthy, sustainable, and cost-saving concepts in construction. As per LEED, materials that have been extracted, harvested, and manufactured within 500 miles are called as local materials. If we are using the local materials, then the transportation cost will be considerably reduced so that we can reduce the emission of the carbon dioxide. Major international rating systems like LEED are the first one is the LEED, that is Leadership in Energy and Environmental Design, developed by the USGBC, which is used globally. Then the another one is BREEAM, that is Building Research Establishment Environment Assessment Method, which is the oldest system which is followed in UK. Next one is Green Star, which is used in Australia, New Zealand, and South Africa. Another one is CASBEE. This is the Comprehensive Assessment System for Built Environment Efficiency, focuses on environmental efficiency at Japan. Another one is DGNB. It means the German Sustainable Building Council, which strongly emphasizes on life cycle performance. Another one is WELL or Well Building Standard, that is focuses on the occupant health and comfort. So the comparison of green building certifications, we can compare with everyone. The first foremost one is LEED. The another one is BREEAM. Another one is Green Globe. Then Living Building Challenges. Then GBI, which is based on the Malaysia. So all the standards are established to reduce the emission of the greenhouse gases like carbon dioxide and methane, but the assessment procedure is somewhat different. Here, BREEAM uses five-tiered rating system to certify the projects. The five rating systems are the first entering system is the pass, another level is good, then moved to very good. The fourth one is excellent, and the foremost good thing is the outstanding. The outstanding level is the reserved for buildings in the top 1% globally, which is representing true innovations to control the greenhouse gas emissions. The pass level reflects good practices and performances outstanding for the 75% of the standard buildings. The project must earn at least 35% of total 1000 points to achieve the Green Globe certification. The certification has four levels determined by the percentage of the points achieved. So the globe certificate, green globe certificate, this is totally different from the previous one. Here we can rate with the number of globes like 1, 2, 3 and 4 globes. So one globe means the points lies between 35 to 54 percentage, that is the entry level. Then two globes means start with the 55, end with the 69 percentage, that is the next level, and the third level initiate with the 70 percentage and end with the 84 percentage, that is the third level, and the four globes is the extreme level certificate. That certificate is responsible for the 85 to 100 percentage mark out of the 1000 points. So the higher ratings reflect the greater environmental performance and project sustainability excellence. In India, The green building rating system is based upon the GRIHA, that is GRIHA, Green Rating for Integrated Habitat Assessment. This is the India's national rating system by TERI and Government of India. It is the India's national rating system for the green buildings, which is developed by the Energy and Resource Institute, simply called as TERI, and adopted by the Ministry of New Renewable Resources Energy Systems to assess the environmental performance of buildings throughout their life cycle. So IGBC rating system includes the green homes, factory, campus and etc. and Eco Nivas Samgita, which is focused on the energy efficiency of the residential buildings. Other notable systems are ENGE, that is Excellence in Design for Greater Efficiencies, EDGE, which is popular in developing countries, but it is very simple and cost effective, and it leads to the Living Building Challenge, one of the most stringent green certification. And role of IGBC in India, that is Indian Green Building Council, it drives the sustainable construction in India through rating systems, certification, awareness and policy support. This rating system is different for the buildings like green homes, green factories, green schools and green cities. These systems guide designers to build energy efficient and sustainable structures. The Indian Green Building Council is headquartered at the CII office, that is Sarvoji Godrej Green Business Center, Hyderabad, India. Additional regional chapters also available at major cities in India, like the metropolitan cities Chennai, Bangalore, Mumbai, and Delhi. These chapters supports local projects and gives training to the construction people and giving the certification activities. And the certification of the green buildings evaluates the projects as certified silver, gold, platinum. Certified is just entry level. Silver is that is the second level. Gold is the better level, and platinum is the best level. That is the top level certificate. It encourages builders to achieve higher sustainability standards. Promotion of energy and resources efficiency, which is focused on reduced energy consumption, water conservation, especially of rainwater harvesting, then wastewater management, then it supports the India's carbon reduction goals. And it creates the awareness, training and capacity building. It conducts workshops, training programs and conferences. It educates the architects, engineers and students about the green construction. What are the possible ways to reduce the carbon dioxide emission from construction and buildings? First, we can go for the alternate materials. Bamboo is the best material which can be used as the reinforcement. It is very good at absorbing of CO2 and releases 35% of its oxygen from the standing tree. Since long centuries, bamboo has been an excellent material and it can be used as a structural and non-structural material like scaffoldings. Bamboo is not good in shear, so that stirrups always should be in steel. For stirrups, we should not use the bamboo as the reinforcement. So here bamboo here we can regenerate it. That is the main good thing in construction. Nowadays, we are not at all using the bamboo. We have to create awareness among the students and other stakeholders how the bamboo can be used as the reinforcement in construction. So here we can adopt the main reinforcement like this, which can be treated bamboo. And we can compare the properties of the bamboo with the steel. Elastic modulus, bamboo, it is 2 into 10 to the power of 5. Steel slightly increased, that is 2.1 into 10 to the power of 5 megapascals. Compressive strength, bamboo, it is only 20 to 36 Newton per mm square. But steel, the minimum compressive and tensile strength is 250 Newton per mm square. And here the tensile strength, if we want to compare, for bamboo maximum we can go up to 150 Newton per mm square only, but still it start with the 250, and nowadays we are able to get FE 600 also. But even though it is 150 Newton per mm square, uh, the tensile strength bamboo has, we can use it as the reinforcement material for temporary structures easily. Next one is we can go for the cement replacement. Cement, it releases equal amount of carbon dioxide while production. So nowadays lot of measures are taken to reduce the carbon dioxide from the cement manufacturers. Lime is an ancient material which is used for the building construction. Hydraulic and non-hydraulic lime are the categories of the lime. It is an alternative material for cement and is used in energy conservation. It has good workability, durability and self-healing properties also. Due to its alkaline nature, it is highly resistant to acids. And we can go for another one, that is the fly ash. Fly ash is the residual substance resulting from the burning of coal. Is often regarded as the most readily accessible and underutilized resource on the global level. The global annual production of fly ash exceeds 900 million metric tons. So here fly ash has maximum advantages. It can be easily mixed with the cement while manufacturing. And when we compare with the cement and fly ash, the particle size of the cement is not round, but fly ash particle size are perfect round. So that when we are mixing the fly ash with the cement, the workability of the cement can be increased. And another one is the fly ash can be easily reacted with the calcium hydroxide in the cement, and once again the cementitious products will form, so that it is the responsible for the secondary production of the CSH gel, so that simply we are able to get the high strength concrete. And fly ash is the waste material which is available at the thermal plants. This waste material can be converted into wealthy material uh, when will be mixed with the cement or partially replaced by the cement. So the Portland cement has been manufactured with 5% replacement of the fly ash as the performance enhancer. GGBS is the ground granulated blast furnace slag. It is the one of the important mineral admixtures, and an abundant quantity of such slag is available as an industrial byproduct. This has more calcium oxide and silicon dioxide content and is considered as the supplementary cementitious material. Silica fume metakaolin rice husk ash and sugarcane bagasse ash are the few examples of mineral admixtures employed for cement replacement, and the supplementation of these mineral admixtures in concrete as cement replacement material proved to be superior when compared with the ordinary Portland cement. When we are using that fly ash, GGBS, silica fume, metakaolin, rice husk gas, and the remaining byproducts, the particle size of these products are very less when compared with the cement. So the pore structures which are present in the cement are easily filled with these byproducts, so that the permeability of the concrete can be reduced easily and the performance can be increased. Then we can go for the recycled aggregates. The recycling of construction and demolition waste has significant potential for reducing the demand for the natural resources, namely natural aggregates. Nowadays, they are treated as C&D waste, that is construction and demolition waste, as well as these associated cost of transporting and disposing of such waste materials also to be considered. But we can reduce the construction cost by using the recycled aggregates, both fine and coarse aggregates. And manufactured sand is nothing but M sand, is an eco-friendly, high-quality artificial sand produced by crushing hard granite rocks into fine particles, offering a sustainable alternative to river sand. It features angular shape for better concrete binding, and it is free from impurities. So it ensures a high consistency for concrete and plastering work. And the advantages are the cost effective, we can reduce the cost up to 40 to 50 percentage less than the river sand. And strength is more, it offers high compressive and flexible strength to the concrete. Wastage is zero, so no cleaning or sieving of the river sand is required. And sustainable, it reduces the dependency on the natural river beds, so that we are able to protect the river, and by protecting the river, the groundwater level can be increased, so that the agricultural works will be maintained somewhat better. And the sustainable construction techniques are prefabrication and modular construction, 3D printing in construction, passive design, that is natural ventilation and lightings, efficient structural design to reduce the material usage. These are some methods of construction to reduce the carbon dioxide emission. And renewable energy integration, it should be implemented at the all buildings, and we have to insert the solar panels at buildings. Then we can go for the wind energy wherever it is applicable. Then net zero energy buildings to be designed. Then energy, energy efficient systems like LED and smart controls to be applied at the residential and the commercial buildings also, so that we can maintain the carbon neutrality, or the carbon emission can be controlled easily. The benefits of carbon-free construction are it reduces the impact of environment, it saves the energy and operational cost, it improves the air quality, and lifespan of the buildings will be increased. It supports the sustainable development goals. And the challenges in the adaptation of the carbon-free construction are the initial cost will be more. So high initial cost we have to bear. Then limited awareness and expertise among the public. So we have to create the awareness from the school, colleges and universities. And availability of materials we have to search, and we have to select the better best materials for the construction. Then need for policy and regulations, up to now there is no strong policies and regulations are not available for the uh, to control the carbon emissions. So if policies are strong, then the carbon emission will be controlled easily, and technology adoption barriers to be removed, so that easily these systems will be adopted by the public. So the conclusion is carbon free construction is the future of the society. it is very essential to fight with the climate change. It requires innovation and collaboration among with the certified industries. Here, engineers' role is very important. Engineers plays the key and important role in the sustainability through carbon-free construction. So, whenever we are selecting the materials, we have to go for the carbon-free construction materials. Then we have to design accordingly. Then the construction procedures also to be changed, and we have to go for the alternative methods which are producing very less carbons. Then we have to the building services to be improved, like that the engineers can easily adopt these things, so that publics also can use this carbon free construction materials and the methods easily. Thank you so much for watching.